Hello, I'm going to show you how to solve these types of questions in FP2. Where you have one complex number divided by another complex number, the argument of that equaling an angle. In FP2 they show you a rather weird method, which I personally don't like, and I'm going to show you how to solve this algebraically. First you split the arguments up through the identity. When you have two things divided in an argument, you separate them and they become minus. And that's generally the first step. It's shown everywhere in the FP2 book. Then you take this and you replace it with a variable. We'll call it theta because it's an angle, and this one a different one, phi. Let me just define z1 and z2. Z plus 3, z minus I. We're going to say theta minus phi is equal to pi over 2. The whole idea of this method is to use tan in order to express this in terms of x and y, and I'll show you how to do that now. You take tan of both sides. You use the identity for tan to simplify this, express this in a different way, which is tan theta minus tan phi over 1 plus tan theta tan phi. That's from C3, I believe, equals tan of pi over 2 is infinity, so we'll leave that as undefined or infinity. Now, we have a fraction equaling infinity. You should know through basic algebraic manipulation that this means that the denominator must equal 0. In order to have undefined, when you're dividing, the denominator has to equal 0. So we take the denominator equaling to 0. Now, we said theta was this argument of z1, z plus 3. If we take tan of the argument of z1, this is defined as the y component of the complex number, which we can rewrite this as x plus I, y plus 3. The y component is simply y. There's nothing else, no other imaginary parts apart from y. So we say the y component over the x components. The x components is the real components. The real components are x and x plus 3. So you put it over that, put some brackets, and you do the same thing for phi. This is x plus I, y minus I equals x plus y minus 1 I. So the y components are y minus 1 over x equals 0. Bring the 1 to the other side and multiply these brackets out. Y minus 1 over x plus 3 equals minus 1. Multiply both sides by x plus 3. Minus x plus 3. Then you open the brackets out. Y squared minus y equals minus x squared minus 3x. Bring everything to one side. X squared plus y squared minus plus 3x minus y equals 0. Now we'll complete the square in order to find an equation for this circle. So x squared plus 3x plus y squared minus y equals 0. X plus 3 over 2 squared minus 3 over 2 squared plus y minus half squared minus half squared equals 0. X plus 3 over 2 squared plus y minus half squared minus 9 over 4 minus 1 over 4 equals 0. X plus 3 over 2 squared plus y minus half squared minus 10 over 4 equals 0. X plus 3 over 2 squared plus y minus half squared equals 10 over 4. So this is an equation of a circle, and we will use that to describe the loci. The center of this circle is minus 3 over 2 half radius. It's not useful information, but we'll use it anyway. Root 10 over root 4 is equal to, I'll leave root 10. Root 10 over 2. Now we can use this, let me put this on the camera, to draw our loci. Draw the axes. Go back to Z1 over here. Z1 is Z plus 3, which means the X value is minus 3 and the Y value is 0, so we'll put it here. Minus 3, 0. And for Z2, the X value is 0, the Y value is 1, so we'll put that there, 0, 1. Now the problem I always found in the method given in the FP2 book was which side to draw it on. I could never figure it out, even with the explanations they gave. But with this method, we know that the center is minus 3 over 2 half. We'll write that here. Center minus 3 over 2 half. Draw the center onto the diagram. Minus 3 over 2 half. The center is in this quadrant of this circle. The center is in this quadrant. So you draw the semicircle, which is in this quadrant. It's a pathetic semicircle, but whatever. And there you have it. That's the loci. You can draw in this if you wish, in order to show the pi over 2 degrees. That should touch the. It's pathetic. But that's pretty much it. And that's how you solve a complex loci using algebra. This form only. The others are much simpler to do. The FP2 book method works very well for me, and I'm sure it works for you as well. Thanks for watching.